Okay, so you're all welcome to the second section. I hope we were able to do a bit of hands-on for the day that we were not able to meet us yesterday. So, just a recap for the first training we did for the introduction, and then we did for the why we are using the software because of its free usage and then its application to a lot of institutions that probably use. It has more applications in most platforms, and it is applied in both Microsoft and then on Mac. So we went on the interfaces, and then we also did types of the data types. That is the integer, and then the numeric, which is the double. That's the one that is with the decimal. Then we did the types of statistical analysis. So as I said, once we are able to know the types of data we have, then its application, the type of analysis you are going to use to analyze your data comes in handy. So as I said, first of all, you have to get a grasp of these data as in if it is scalar form or in vector form or in matrix or in a volume form or the Vossel form. So I think we were able to do a hands-on on the scalar in which we were able to multiply, subtract, and do the exponentiation, and then do for that of the vectors, in which in the vectors we were able to do presentation of the data. I think when we were closing the last time, I requested that the types of data we are expecting in our project or in our work, we should bring on board so that we can use those data for some of the examples we'll be using for the work. Were we able to get how our data are, as if it's in vector form, or in a matrix form, or in a whole volume, as the voxel? Anybody with uh, able to get how their data are presented or are taken from either the field or the laboratory? Please, you are muted. Doc.
Yeah, I have a data. Um, I don't know, but it's an Excel file.
Okay. Okay. All right.
So
Okay.
maybe I can
Okay.
just show. Pardon?
All right. If you have, you can just let us have an idea the type of data you have, and then we all get on the same page as in if it's in vector form or in matrix form or in a Excel.
Okay, I think the data has a multiple dimensions, so
Okay.
probably it will be more fitted for matrix.
Okay. Okay.
Ye-
Okay.
Yeah.
That's fine.
Mm.
Okay. Okay.
And they were collected at a different time points,
Okay.
like on the same participants, but different time points.
Okay. 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 So that is the time factor dimension in the data. Well noted. So you consider such data. So for me, I was thinking of more of spatial. Here's a four factor here. I was talking about the spatial, that's X, Y, Z. That is in a specific volume. But here, the dimension of time has effect on the data that you have. So in this case, it will be a four dimension or a data that is influenced by four variables. That's the spatial, and then X, Y, Z, that's the volume or the area that it was taken, and then the time. Okay, so all these will help with the help of this code, you'll be able to present it in a more understandable way than to be talking too much. So if you're able to present your work and your data in a visual form these days, it speaks volumes and it's more understandable than to be doing more of the statistical presentation and then talking of and use a statistical presentation to as backup to it. So with the help of these codes, we're able to do all this. Please, anyone yet? Okay. Or we continue as with time. can share the type of data you are expecting.
Yeah, maybe we can continue and then
Yeah,
share.
yeah. Yeah, so I think I will share my software interface and then we'll start working on the various examples we started last time and then move on to the three dimension, that is the matrix data. So I'll exit this presentation. Okay, but before I do that, yeah. So with the vectors and then the matrix, the syntax that is mostly used is what I is showing currently in the slide in this slide. So there is a syntax for the vectors. That is with the vector, you just have to put the C and then bracket. Oh, it's not, sorry, it's not in now. Let me put it in the presentation mode so that you see there. Yeah. So I hope my cursor is visible on the.
Yes.
Yes. So as you can see, this is the command for the vector, the syntax. That is the language that you type in the console section that you create your array of data containing your results in a one-dimensional form. That is one-dimensional form. In this case, it will be in a vector form. And then the syntax for matrix is you just type matrix and then you input the various dimensions in it. And the second syntax for matrix is either you combine column bind or row bind. So if you see the C here, the C here stands for column. So you will be given a set of data in which in a vector form in which by saying C bind, that means array the vectors in a column form. So that will form the matrix. But if you say R bind, that means you're arranging the vectors in the matrix bracket in a row form. I hope we are all on the same page when you talk about column and then row. Yes or no?
In
Yes.
in
Yes.
Excel?
Yeah,
This
yeah,
is yes.
it runs through that the column is the vertical one. The
Yes.
row
And the row
is
is
that is
horizontal.
The
yeah,
horizontal.
horizontal. So if
Yeah.
as you see this one, yeah, the row is horizontal. So I'll exit this one and then I'll share the application. Yeah. I hope is my interface visible.
Yes. Yes, it's
All right.
visible. Mm.
So please don't get confused. So let me clear all the contents here. I was doing earlier work here, so let me clear the content. So as you see, with this brush, you can see once the cursor is there, it shows that clear all history entries. So I'll clear so that all those entries there will go. And then once it goes, the view of it also will go. Okay, so we're left with the console. So, I mean, as a refresher, we will do one of the start with the vector and then move from the vector to the row. So as I said, the syntax for the vector. So if I want to form a data with represented by a variable, maybe I don't want to use just a letter. Okay. So lab one. So that is unknown. So the pointer will what face the lab one. Then the minus sign. Then you form your brackets. Then in the brackets, you input your results. So as you see, 1, comma 2, comma 4, comma 5. You always have to separate it with a comma for it to know that it's a complete entry you have done. 7.4, 6, Point
Good evening,
three.
Doc.
Yes.
Yeah. This Doc, if you are not using the source, can you minimize it so that we can see? Because of our screen, when you type down there,
Ah,
we can't see
okay.
it. But
Okay.
if there's a way to minimize the source, or
Yeah, I will.
thank you very much.
Yeah. So then yeah, you see the mistake here. I missed the syntax C.
Okay.
That's why the error is showing. So I'll go back to my input and then put the cursor there and then type C. So that is the syntax for. So after that, if I type enter, it will be able to give or save the results in the variable lab1. That is data that was collected in laboratory 1. So that will be creating a vector for lab1. And as I said, when you have these, you can visualize it by just typing plots. I hope we are all doing hands-on on that lab1 alongside, or it cannot, it's difficult to multitask.
We
So
trying.
just plot. So yeah, okay. So if I say plot lab1, it will be able to plot and show the.
Doc, the last number, is it a comma 3 or dot 3?
Yeah, instead of yes, it's dots. It's a double value.
Okay.
Mm. That's a decimal.
Okay.
8.3.
Mhm.
So ideally, it should show in the plots window, but so I'll stop sharing and then go to. So that is visualization of my lab results 1.
Okay.
There are a lot of, syntax or command I can use to further make it more, presentable, as in the axis and then the title of the plot. All those syntax command will come. So this for just for starters. So we just use plot for now, and then with time we add more syntax to make it more presentable.
Please,
So there are a lot
can
of.
I see what you typed with the plot before we got the results? Can we go back to the other
Okay,
interface? Mm. Okay, so plot and then into bracket lab one. Okay, that's
yeah. So plot lab1, that's it.
fine. All right.
So as I said, so I think this is just a recap of the last session. We were able to do up to vectors. So I think we have to use the syntax for the matrix. That is a data that is in 2-dimensional. So if you hear a matrix for as in maths, you're not going to do any mathematical work here. It's a data that is in a what? 2-dimensional. Okay.
Mhm.
So, and that is what we call that arrangement is what we call the matrix. So if we have a data that is in a matrix form, the syntax for it will be max. Is it? Yeah. So before you do that, you have to assign that data to a particular variable. So maybe lab2. And always the pointer is to the variable. So lab2, then assign to the matrix. So yeah, so the matrix as I said, you can just write maths and then a range of values. So I can say 1, 3, 5, 6. Okay. 1, 3, 5, 6, 7, 3, comma, 4.2. So the number of values in the type so far is 1, 2, 3, 4, 5, 6. And then I have to tell that, as I said, this values, comma, have to define the number of rows. So if I have 1, 2, 3, 4, 5, 6, 7, 8, to form an if I form a row of 2, definitely I'm tied. My hands are tied to form a column of what? 4. So if I say number of rows, that's n row equals to. So this is the data I have, n row. Then I'm saying the row is 2. That's the horizontal section. So if you have a data and I said the row is 2, and then the data is 8, then definitely once I define the row, the number of column becomes fixed. So COL is equals to 4. If I make it 5, that means I'm creating a space of 2 times 5, which is I'm creating a dimensional space that will be filled by 2 times 5. That is 10. But here's the case. The data I have here is what? 8. I think you have seen what I'm.
Are you counting the 4.2 as two
Yeah,
values?
it's a double.
Okay.
Yeah, it's a decimal place. It's not a comma.
Then, Doc, please, they are 6, though.
There are 7. That's what I'm thinking. There are 7.
Oh, there are 7, eh?
Wait. 1, 2, 3, 4, 5,
It's
6, 7.
1, 1, 3, 5, 6, 7.3, 4.2. It's 6.
There is
6,
3.
all right.
There is 3 after the 7. Oh, it's
Yeah,
7.3. Oh,
7.3,
okay.
4.2.
It's 7.3.
Oh, okay. Got you.
So definitely then so that means I have 6 values in the data section of the matrix. So if I'm making a row of 6, then definitely my hands are tied with the column of what? 4. 4 times 2, sorry, 3.
3.
Yeah. So you see, it's giving me an error. So now let me say lab pointer lab. Let me see. Okay, let me just use y, and then I use a pointer. Then I go and copy the data. Because if you put it singular in the syntax of the matrix, it doesn't recognize it. So I have to assign the whole of this data to a variable.
Okay.
You understand? So and paste. So it's a vector, right?
So see.
So you see why I gave an error in the first command, the earlier command. I was assigning it to a vector, right? An array of numbers. But that's not how this is not the syntax for assigning an array of numbers to a variable.
Please, can you explain again why you got the error?
You say the reason I got the error is that I omitted the syntax for vectors.
Oh, okay. Got you.
Yeah. You see, I omitted the syntax for vectors, in which it has to be C, held into brackets, the list of.
So for example, if I'm going to go with lab 2, it means that I can clear the matrix and then put C there before the bracket and it should work, right?
That is lab 2.
Yes.
No. You see, if you put C there before the matrix.
No, without the matrix, I remove the matrix. So
yeah, exactly. So that it will take those values. But remember, you have to remove the row and then the column.
Oh, okay. Got you. I understand now.
Yeah, Kwaku, please.
Doc, I would like to take a step backwards.
Yeah.
Why was there an error with the matrix syntax?
I want to highlight it. This one, right?
Yes, please.
Yeah. The error is that here the data has to be in either in a vector form. It doesn't see it so I could equally make it lab 2 copy. Let's try this. Okay. What I'm saying, it doesn't see here the syntax for matrix. You see where I've highlighted. It wants to see it in a data form. So maybe I can rather put C, and let's see if it will see it. So this one, it is telling it that it's a vector.
Oh, so Doc, what we are
Yes.
saying is that first, before you can assign a matrix number of data to a variable, you must first have it in a vector form before you can convert it to a matrix. Is that what you're saying?
Yeah, what I'm trying to say is for matrix, there's a format.
Okay.
So I say, okay, let me see. Yeah, for matrix, if you enter it in individual form like this, 1, 2, 3, it will not be able to arrange it. So here in matrix, if you check in the manual, it is like this is what is here, data. But if you put the data in a raw form, it will not be able to know if it's a vector or a scalar. So definitely you have to define it that it's a vector.
It's a vector, okay.
Yes,
Okay.
yes. So the question Kweku asked, that's why I have to go back. You see the earlier one, I put it without telling it that this is a vector. That's why I got it wrong. You see the one I've highlighted. So I have to go and copy it all again. And then, as I said, the syntax for the syntax for vector. So I come and put that C in a bracket so that it will know that this data it is saying here is what? A vector. And then you have to bring a comma for it to know that the input of vector is finished. So now it's going to read the input of row and then input of what? Column before it can present the work. Please, any question? Just take it easy and grab it here, and then the rest will just follow.
Okay. Yeah, so up till now, I understand, right? Now, this assignment we have given to lab 2, how do we now see the data arranged in 2 rows and 3 columns?
The lab 2 here.
Yes.
So the data we have here, C in bracket is what type of data? It's a vector type. What I've highlighted here is the syntax for creating a vector. Yeah. So when it sees it, it knows that it's an array of numbers.
Doc.
Yes.
So the numbers in the vector numbers.
Yes.
Assuming you have, let's say, the numbers maybe for your data, how do you know that this arranging of the numbers in the rows and columns, how do you know which one goes to which row and which one goes to which column?
Yes, we will come to it. That's why we have a syntax for commanding it that you have to plan. That's what I'm saying. Grab it basic first. The rest, you know how you arrange it.
Okay.
So the earlier one gave me an error because I didn't put the vector syntax here. So I've corrected it and then press enter. So now lab 2, it can easily read it. Alternatively, I was about to assign the whole of this to a variable. You see the highlighted one?
Yeah, you actually did.
Yes, I did, but Kweku asked a question that, why is that it gave us an error? That's why I said, okay, let's correct that one error first before we can go on that step. So this step is fine. And then there's other step I wanted to use, which is this, copy, paste. You see, now I'm going to assign this entire array to a variable called what? YY. So I press enter. So now YY consists of an array of 1, 3, 5, 6, 7, 7.3, and then 4.2. Any question? So then I go to the syntax for the matrix. So instead of putting the entire syntax for the vector, I have represented already with what? The variable YY. And it will give us the same results. I think you know where this YY is coming from.
Yes.
Yeah, so I press enter, and then it gives us the same matrix. lab 2. So instead of typing the whole of this here, I decided to do it step by step. I rather assign the whole of this to what? YY. Please ask questions, because I want you to understand this, how you arrange your results in a matrix form, in a vector form, and then once you get it, we are good to go. Any question?
So I'm taking us a bit back to
Yeah,
the scalar, the vector, and then the matrix, right?
yeah,
So for scalar, you can assign the number to the variable directly, and then
yeah,
for the vector, you have to use the vector syntax, which is C, before
into
you put
brackets. Yes.
the series of numbers, and then you can assign it to a variable. And then for matrix, there should be, of course, the matrix, and then the vector command or the vector syntax and before the numbers.
Yes. How
Okay.
you want the numbers to be arranged in matrix. That's it.
And then how
Row.
you want the numbers to be arranged. Yes, okay.
Yeah.
Thank you.
So after that, then we are saying that we are creating a results of 2 by 3. So let's have a look how our matrix lab 2 looks. So you type lab 2, enter. So are you seeing the right matrix? Number of rows is 2. First row, and then second row. Then a number of columns. First column, second column. So this is the first column. Right? Forget the top one. These are not parts. It's just telling you, it is labeling the rows and then the columns. The one I've highlighted at the top, you see that is in brackets.
Yes,
It's not part of the data.
it's the number of columns.
Yes, it is just indicating that
Column 1,
the
column 2,
numbers
column
that
3.
falls under it are under column 1. And the 2 here is telling us that the numbers that fall under it are in column 2. And then the 3 here tells the number that falls under this are in column 3. Then the 1 here is telling that the horizontal values that correspond to the 1 here are in row 1. And then the 2 here is telling that the horizontal values that follows are in row 2. So let's see how it arranges. It skipped 1 at a time. So every 2, then it picks. So now number of rows is 2, right? So when the number of rows is 2, it jumps one step. So here you see that it picked 1, then it jumped 3, then it picked 5, right? Then it jumped 6, then it picked 7.3. So that will form the 3 rows. Silence. All right.
Yeah,
So let's do the
we understand. We're following. I would have a question, but I wanted you to finish what you were explaining before.
Okay. Please do.
Should I ask my question?
Yes.
Yeah, so I think it boils down to what Koku was trying to ask as well. Can you determine how the arrangement should be done, or which numbers should fall under which row and under which column?
Yeah. So
Okay.
as I said, first of all, this is row 1. Please, someone, I will answer your question for let's maybe what please ask your question. Is this Sapua?
Sapua?
Okay.
Sapua.
Doc, thank you very much. The name is actually Silas, and that Apua, so it's a short form.
Okay.
Yeah. So before we got to this place, I was just trying to get the rows and the columns as well, because someone also asked, how do you determine that the rows were 2 and then 3? And when I wrote it down, it looked as if I'm just trying to think aloud. Maybe that could be the reason why. That the first the number of rows tells you that, so that you take the 1 at the first row, the 3 the second row, then the 5 falls again into the second column, then the 6 to the second row of the second column, then it goes that way. So if you had set 3 rows by 2 columns, it would have gone 1, 3, 5, then 6, 7.3, 4.3. I think that also make logical
Yes,
sense. I don't know how that we can
I
see it.
understand. Yeah, you have a point. What I'm trying to say is, since this first example is getting difficult to get how it arranges it. So that's why I said, let's do a second one. Okay. Then change it. In this instance, this is row 3, column what?
2.
2. And mind you, in your results, you will have your matrix already, because in your results, it will be in a matrix form like this. So it is up to you to say there's your row 1, row 2, row 3. So you pick from your results how you arrange them. But let's see how it arranges them. Okay, so lab 2 now, instead of 2 rows, now we are making it what? 3. 1, 2, 3. You do 2 lines. Oh, I think
And we label this lab 3.
okay. Then let me do the earlier one, lab 2. Yeah, this is the earlier one. So I override it. Then this one will be lab 3. Enter. So I type lab 3. So this 3 rows, right? 1, 2, 3, and then 2 columns. I think yeah. So we pick 1. Where's the original? Yeah, 1.
1, 3, and 5. First 3
Oh, okay.
for the first row. For the first column, sorry.
Yeah. Okay. So now you see the pattern. You pick this and make it in a column form. Are you seeing it? So
Yes.
for row, it take this and then turn it upside down and make it column 1. I'm talking about lab 2. It picks 1 and 3 and make it 1, 3 and make it column 1 here.
So, Doc, basically, it's arranging it column wise first.
Yes.
No.
Yes.
No.
1, 3, 5, 6 is arranging it column wise first. So 1, 3, column 1, 5, 6, column 2, like that.
7. So
Point 3.
so as I said, is it this is the second one, row 3, right?
Yes.
Yeah. So row 2, 1, 3, then you do it in a column wise. 3, 5, 6. That's what I did. The second column. Then that's it. So the same thing for row 3. The number of rows will increase. So we make it will pick 3 values.
That's 3 values.
Yes. So it will pick 3 values and make it vertical. 1, 3, 5. The next 3 values, 6, 7, 3. 6, 7.3, 4.2. So if I do lab 4, the values are 6, right? 3 to 6.
Yes.
So you just pick the numbers just by that. So if it's 6, so it picks all 6. I have no option than make here what? 1. So 6 times 1 will give you 6 spaces to fill your data. Oh, yeah. So this will be lab. I know. I mean, just have a particular style. It puts it. As I said, it picks the first. So let's do more examples, and then you understand. So
Okay,
lab
Doc.
4. Yes.
Yeah, so lab 4, I have a suggestion. Let's add 2 more
Values. Okay.
Yes. Or 3 more so that it will be 9, and then we will do row and column the same
Okay,
way.
and then we appreciate, yeah. So I'll make here this one lab 4, right? Is that
Yes,
what you're
please.
saying?
Yes,
Lab
please.
4. Then add
8,
8,
9, 2.
2. So in this instance, we have how many values?
We have
9, right?
9, yes.
Nice, yes. But when you multiply 2 times 3, it's not 9. So that
So we
means
do
you have
3,
to
3.
change. Yeah, that means you want 3 by 3 matrix.
Yes,
That I'm
please.
saying, your matrix, how you define your row and your column, is based on your data results.
Okay, got you.
You understand? Your data results will let you know which is going to be your row and which is going to be your column. And it starts by understanding these basics before you can apply it to your data. Okay, so 3 by 3, enter. Then type lab 4. So as you see, you pick the first 3 and then make it column.
Yes.
Make it column. Then pick the next 3. Yeah. And make it column. Hey, sorry, it's up to here. And make it column. Then the last 3 and make it a column. So I mean, with time you get to know the pattern.
I think the number of column is the deciding factor of which numbers to pick
You
first.
pick.
So
Yeah, yeah.
if you
If
are
the column
counting,
is yeah, okay. I think that one too is a good thing.
so let me ask some practical question here. Let's say we have a data, okay, of age of boys and girls mixed up, okay,
Yeah.
and let's say we have 5 boys and then 5 girls we've collected, and when we record 1 boy, we record that 1 girl. We record 1 boy, we record 1 girl. So in this case, if you want to sort out your data into rows and column, one. Yeah, Michael,
So
you are
Michael,
writing on the screen and I'm recording, so please.
Michael, okay. So as you are saying, so this is what you are trying to say,
Sorry
right?
for that.
So the data you are saying, you said boys and girls data, right?
Yes,
So let me
please.
represent it BG. Yeah, then I'll assign it to, you say a big boy, right?
Yes, please.
And remember, this B. I represent boy with B because boy is not a quantitative value, it's a qualitative. So the B will be in what? It will be, well, it's not a scalar, it's rather a string. So it has to be in what?
No,
Inverted commas.
let's do it this way. So we have collected their ages. So now their age, the number we're going to use their number, the age of, like, the age is a number, right? Okay, maybe you want to do something, but you go
Yeah,
ahead.
so let's start with this first. So this is the data you're talking of. Then comma, girl. How many are there? Comma, boy, comma, sorry. So 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5. So 9, right?
One more.
So this will be our representation of boys and girls in this thing. So now you want to arrange them. It's like this. You say, how do you want to arrange them? In a matrix, 2-dimensional, right?
Yeah, so five rows and then 2 columns. Yeah, in the matrix, yeah.
Matrix.
Yes. Sorry. Gotcha.
So matrix.
BJ. 5 rows. Two columns.
2. You see that as I seated there. Yeah. So lab 4. So this is how I want to see. But if, as you say, figure are not distinctive. So it's difficult to say that if you put a boy's age here, it will be difficult to differentiate the number that it is a boy's age.
Okay. So is there like a command you can give to arrange all boys' age in the first column and then all girls in like a second column?
Exactly.
Uh-huh.
So in this case, you say all boys in the what?
The
In the
first.
first column, like here.
Mm-hmm.
So let's see. Then in this input, it will be difficult for you to sort it out.
Okay.
Yeah. Unless you have to edit the input. You have to come and edit it here.
And make all the boys first and then
First,
the followed by.
exactly.
Okay.
Yeah.
Okay. Got you. Got it. Noted.
Yes. So please, I think we are on the same page. Are we? Please ask
Yes,
questions.
Doc.
Because if you're able to visualize your data in 2 dimensions, 1 dimension, the scalar, and then there's 3 dimension that is in a volume form. Because sometimes you collect data in a field that's on a flat surface. But in Earth, what about if you are doing air sample? It's not going to be one area. So you can pick the one on the ground, one in the middle, and then maybe one at the top. In this case, the one on the ground will be a matrix for the ground. The one at the top will be another matrix at the top, at the middle, and then the one at the top, another matrix in the top. So in this case, it will not be 2 dimensional. In this case, that's work you are doing is in 3 dimensions. That's in an entire volume. So once you're able to visualize this, programming how to sort your data in such a huge volume becomes easy. You see the program to be very huge, but it's just sorting, it is sorting. Because repetitive manual, if you are sorting a data of maybe 1,000, therefore you will do a mistake. But when you are writing the code, the script to sort it out, that one, computer will never do a mistake. So
Oh,
with maybe,
okay. So
you
if I
understand?
get it right, let's say we have a column, we have collected data in Excel, and then the same on boys and girls, let's say the same age, maybe
Yeah.
about 500 people. So then you can write a script to say that put all the boys, the age of all boys in one category, and then put the name
Yeah,
of
yeah,
okay,
yes,
okay,
only. Yeah,
okay.
it took the script to do it. You just entering sorry, pressing enter and then do it with less than 5 seconds. But
Okay.
mind you, writing the script will take you some time.
Mm-hmm.
Yeah, but when you finish writing the script, the job it can do is enormous. Because you collect data from here, collect other data from another place. You cannot manually be doing them again. But once you have in the same format in the different locations, and the script is written,
Mm-hmm.
straight away you just input the data and then you just get to the results within the shortest time and do all the analysis and do the plotting and everything. So this one, as the beginner, is to just know the basics of how these data are presented, and then the intermediate will be how you write a script to analyze or to
Oh, okay.
sort the data out. So for now, this is the syntax that is sorting or creating a matrix out of a vector. That is just one vector. So now we know that if you are given just one vector, you know how. So if you say 3 by, when it starts by say column 3, that means it takes the first 3 values and then what?
Create a column.
Yes,
You
create
create
a
the
column with
first
it.
column. Mm-hmm.
Yes, exactly. So if you say column 2, it takes the first 2 and then create a column with it, and then
Mm-hmm.
the next 2 and create a column with it. I think that is easier to understand than that is how I see it for now. But I mean, you can have your own way of how it's arranged them. But as I said, you can use this as a guide.
Yeah, I think the number of column is the dependent variable if I'm using X and Y terms.
Yeah. So now we go to the visualization of the matrix. So
Yes.
if you have a matrix like this one, so lab 4. So if you want to visualize this data, so if I say lab
Doc,
4,
we
yes.
cannot. Okay. Now we can see.
Yeah. So you have these results maybe on a field. in which you have taken your data. But most 2D results are always presented in a graphical form, an image form, so that they will use the quantity to determine how deep or how light the color is. So when you see that such an image, you'll be able to know that, okay, in this field, there was this higher concentration at this area. But when you're looking at it in a number form, it's difficult to what? Visualize or to analyze it. So after you have presented your work, you have input your work in the matrix form. Now you can see how the command, I used to have it, yeah. Okay. The command for visualizing is just type image. Let me search.
This time it's no longer plotting, yeah?
No, because what I'm going to see, it will be in an image form, not in a plot.
Okay.
So there is a command to visualize.
The results of the matrix
Yes.
data. Okay.
Yeah. Yes. So this syntax you have to know this syntax. So before you do that, you see that the number of data we have so if you are going to visualize lab 4, in this case, this will not be 100. So the data size will be what?
9.
3 by 3, 9.
Mm-hmm.
So this is the data size. And then these are the colors we are choosing for it. So now you have your color of the data. Then you can type the image one. Yeah. So now you see, so this is a syntax for telling you that you have a data. So this one you just have to know. But once you keep using it, you become part of it. So this is a syntax you have to know when you want to visualize this in an image form.
Did you decide which colors to use?
Yes, I said blue, white, and red.
Okay, so you assign this to color, right?
Yes.
Okay.
The type of color you want to see in the output. So this is just an example. So with time, as you read another color, you know how the types of choice of colors you use and then how to present them. But you see in the image syntax, you see that the next one, the data is there. So it's not the math data I'm going to visualize, but it's what data lab 4.
Mm-hmm.
So
okay.
earlier I did analysis for maths, so which I represent the data by maths, which I wanted to visualize. So this lab 4. And then we labeled both the X and then the Y, but there's no need but just to. So this just as is in the plot command. You label your X and Y as is. So this is just in the plot command. And then this one just stands for the heading of the color map. So the entire this thing is just the heading of color map. So you see that what I was having visualization was for a random normal matrix, which I generated. But this one, let's say lab. And I press enter. So ideally, it should have shown, so I have to exit this and then show it on my plot. It should have shown on the plot. So I'll stop share and then show it on the plot. So that matrix we have, this is how it is visualizing it. You can see the data is 3 by 3, right?
Yes.
1, 2, 3, and then 1, 2, 3. So it is this matrix that it has been able to identify and use colors to present its magnitude. So just as I said, there is just 3 just nine, data of nine. So you're not, I mean, I think you are seeing the representation of the matrix. So this is just an illustration, but for higher values, you can see that it will be easier to use because this one, yes, Kwaku, this one is just you can just look at the data and see which one is bigger. You understand? This is just nine data. You can see that easily see that 9 and then 7 is a higher values. But if you have 100 by 100, 1,000 values, you cannot just easily see the highest value. Sorry, the location that has the highest value. So that's why the color mapping in doing analysis, in presentations, everything is always the way to go. Yes, please, Kwaku.
Doc, please, I would like to know the relationship the colors do have with the metrics because we assign 3 colors, and I can see some of the colors are kind of faded but relate to the main colors we assigned. So is there any correlation?
I mean, for now, there's not. You have to assign the weight of the color to the results with a
So the
special
weight,
syntax.
the weight.
Yes, yes.
Okay.
So for now, the color and then the quantity or the magnitude of the results does not.
Okay. Can you please also go back to the console?
Because
But
if you look at it,
before he goes there, I wanted to understand the scale chosen here. This is also random. Is the scale chosen random and stuff?
yeah.
Okay.
Yeah. So just for presentation. So we will just have, I mean, maybe in the next 2 lectures, how you will quantify how the colors should relate to the quantity of the values, and then how you will. So this is a default presentation in a color map.
Okay.
So this is just to keep your interest to know the syntax for creating a color map. Then the next step, we will know how you will add additional syntax to know how the colors should be weighted to the quantity of values in the matrix. So just for now, knowing how to present a matrix data in a color image or in a color form, that's what I just illustrated. But how the quantities are affected to the weight of the color will be further, input. Yes, Kwaku.
Can you please go back to the console?
Okay.
Okay. I stand to be corrected, but before assigning the various labs to the matrix, we use C because it was vertex, right?
Yes.
With the colors, it also has a C. I'm trying to wrap my head around it, the purpose or the function of the C before assigning the colors to it.
Oh, good point.
Yeah. But this is an array, right?
Oh, okay. Yeah.
But in a qualitative form.
Could you understand what he means?
Honestly, no. Maybe you can.
Yeah, so I think I understand, and maybe I can help you understand it. Basically, the vectors that what we used previously were numbers quantitatively, yeah, and it involves a series of numbers, yeah, and here we are with series of strings. Is that how they are called?
Yeah, strings. Yeah.
Series of strings. So in actual fact, it's also a vector in a qualitative form, in a string form, not in
it's a data. Not all data are in quantitative. So be mindful. Blue, white, red are also a data, but it's that those data are called qualitative data, and qualitative data are represented by strings or characters.
Okay, so does it mean before you declare an array, it must be
C.
Yes.
Front.
Okay.
Yes. There's a syntax for array.
Okay.
C into brackets, then you put the data in it.
Okay, regardless of the nature of it's before you declare any array, it must be okay. Thank you very much.
You're welcome.
Thank you.
So can we by this also say that array of data is also the same as vector data?
Yes, that's what I'm saying. The vector there is just mathematical
term. Okay.
Yes.
Good point.
Yes. So I think did I say yeah? We will I suggest we take time to practice on this, data in a two-dimensional matrices, vectors. Try our hands on and then
I have
let
a
it
question
sink.
before you go.
Yes.
So as a beginners, I
Yeah.
don't even know how you determine the syntax for the command for the image.
Image.
First, so first you had a color and you assign them specific colors,
Yeah.
But so let's say I am to do it. Do I need to, like, can I copy exactly what you have and put my own color numbers, or how do I decide on the
Yes. So as I'm saying,
command?
just let's start with this syntax for now. Just get this syntax for now. Then we will graduate into higher, data. Because mind you, when I copied this one, it came here. Here was not 9.
Yep. Yes.
It was a syntax for 100, a data of 100 values.
Okay, I
But
think I get you. There is a manual that tells you
yes,
you. Okay,
yes, that's what we call it. That's it. So you cannot, if you are defining the colors for the your image, this is the syntax you have to write.
Okay,
Colors.
got you.
So even here, this one is an assignment, right? This is an assignment. That's why the color came here. Because you can see the pointer. Look at the pointer. Because this pointer means you have defined the what? Color.
colors.
Yes. But this one is a standard, the color RAM
Palette.
That one is the language of R. It's a syntax.
Okay.
It's always, if you want to use your color mapping, this one should always be there. That's the language that it sees that you're saying, okay, we are going to consider color or image in which we are going to use the weight of the results to, plot a color map.
Yes, exactly. That is what I wanted to understand, but I think it's very clear now. So
Just
when
when
I start typing color, it should that option can come and I can select
it will come by itself. Yes, yeah. So that is a language for the software. The color ramp is just a fixed language you cannot change. But mind you, we have assigned it to we have referenced it to this variable called colors. That's why in our image, it is expecting that there should be a color mapping it has to refer to. And the color mapping is this color mapping, blue, white, and what? Red. And all these things. The main is a language, is something is expecting. Because when it sees the main, it is whatever it sees there, you put at the top of the color map as what? The heading.
Okay.
Yes, yeah. And this one too is a first language. This and that equals is a first language. But here, whatever it follows, it puts it as what? On the x-axis. Yes. Okay. And then here, you put this one too on the y-axis.
Okay.
So with time, as you keep using the syntax, you get used to, the basic syntax in the code, and with time, you grab. So for now you know the matrix syntax, you know the C syntax, I know the color syntax, and then I know the image syntax, you know the plot syntax. So as these are the basics you need for now. And then, as I said, once you know how your data is and how it's arranged, you will know which one is going to be a number of columns and then which one is going to be a number of rows. In this case, when you are considering a matrix.
Very well noted. I think the last time Michael or Kweku had asked about interpreting the but we can do it at another time, so maybe you can factor that in your next presentation. That's fine.
Okay.
Does someone have a question?
Yes, so I wanted to find out, Doc, so it means that the term X lab and Y lab define the axis.
Yes, it's a language for the code.
Oh, okay.
And that language we call it syntax.
Okay.
It has no relationship with our lab 1, lab 2, lab 3, lab 4.
No, No.
Okay, good point.
You see.
Okay.
Well
So when you
noted.
see Y lab, it's not our lab we are talking of. And
Okay.
in other sense, when you are introducing a variable, it always is associated with a pointer.
Mm-hmm.
Okay.
Yeah. It is always, you cannot just introduce anything that it understands unless you use a pointer for it to know that you are introducing a character in your code.
And the main tool represents the title of what you are.
Yes,
graph.
yes, yeah. Well, that's going to put at the top of the
Thank you.
graph. Yeah.